很真實嘅香港上中華 University。
很高選所有業務主持。
洪一圈 from National Taiwan Normal University.
I'm Hudson from Faculty of Media School.
Okay, now please each team choose a representative to introduce yourself. From the reporter team and then opponent team and then reviewer team.
Hello everyone, and we are anonymous. I'm the captain G2 and his Liu and Yuan Wu is Yu Tingxiang and his Yuming Liu. Thank you for listening.
We're Team Confidential from National Experimental High School, and these are my teammates. I hope we have a best time in this business fight. Thank you.
Hello everyone, we are Wushida Shuai from National Girls Senior High School. Let me introduce our team member Xiang Yingxuan, Yun Ruoyu, Wei Yu, and our captain Huang Yixuan. It's our honor to have a competition with you. Thank you.
The challenge problem is number 4, funnel and board. And the report team have 5 minutes to prepare. Please write the name of your presenter on the board.
Time stop.
Okay. And the reporter, you have 12 minutes for your presentation.
What I made is laser and arrow.说方便的计时的等更新时期就按下压点，呼叫。你那个下一页它没办法跳不到下一页。所以刚开始然后点下一页它没办法跳到下一页。现在刚开始。等我按才能。
那 reset 我跳到下一步，快一点。
我可以配那个，让我计时。我用第四个时候，第10就好。我那我就计时就好，然后人就不管。
啊，可是他要看得到时间啊。
OK 啊，对，我就计时就好。
好，所以你计时他会看到时间。
对。
OK。
他会看到时间。
OK。对。
Hello everyone, my name is Yunmu Liu from the team Anonymous, and today I'm talking to the topic funnel and bow. In our line, do you consider the impulse that air gives to the ball in your equation? Do you consider it in your equation? Yeah, can you show us where? Your equation. Equation. Where is the impulse that air gives to the ball? The impulse. Down. Okay. And so, do you consider the ball is 3 diameter or only 2 diameter? Is it 3 diameter?
Okay, time is up. The opponent, you have 3 minutes to prepare.
OK。好，这个不用写，我这边有了。
他说是。
好 ，OK 的。这个我们看看，然后这个
fixed parameter. How can you control?
而且有时候会甩笔，这地方我不好。
你这一次改变。
对对，它不是改变是我看不到，改变重要。这出题就对。
不行，还要打破。
Stable can rotate，就这个意思。rotate 有意义。然后哪里有讲的是运动这个？哦，然后8。也没有。
上场较大一波。
还有压力什么的，都不是代表
好，那你我现在上来。你去写。
交叉比。
然后它的是这样提高，它现在转过来，这样。
那你问他那个搜寻的方向？
那你用这个讲，它原本是这样子，然后它就是这样，所以现在感觉是这样子。对，就感觉是这个方向，这个方向然后这些球也很起来，所以我就会给球这个方向。我去口上很湿。对，这是。
Okay, the opponent, please take the floor. You have at most 4 minutes for your speech, and then followed by a discussion with total time 40 minutes.
Dear judges, I'm opponent from Team Championship. Then I'm gonna oppose problem for ball and a ball. And the problem statement is that a ball can be picked up with a funnel and blown in the air through it, and explain the phenomenon and investigate the relevant parameter. So the opponent says that the important part in this problem is to why the ball will pick up and not going down, and also why we need to blow air through it. And to solve this problem, this is a structure that the opponent thinks that we can follow to solve this problem. First is why the light bulb will pick up instead of go down, because it's really tricky. And the next is also the limitation of the phenomenon. And the next part is we need to investigate the wind flow velocity. It's the important part of the problem. And the next is how different parameters affect the phenomenon, like the size of the ball or the weight or the velocity of the ball. And the next is the reported outline. First, the theory part that really gave us the cable theory. And they use conduct effect, circular motion, and Newton's law to explain the phenomenon. But they didn't consider the viscosity of the air. The theory, they didn't prove it through their theory. And the experiment part that they use different mass, diameters, and ball, and also the wind speed. But how do you control the wind speed? Because you use a hair dryer, the wind isn't stable. And the diameter will also change the mass. So if you change the diameter, the mass is also changed. So why do you use this to explain why you use this to check what is the parameters? And the next is the conclusion part. And their conclusion is that heavier ball mass needs a higher wave velocity. But why is mass and velocity proportional? And that didn't have clear relationship, and problems is not qualified. And it's a strong and a weak point. A strong point is that they use conduct effect, and the weak point is the light bulb will be rotated, and we can see this through their observation. And they didn't consider it in their formula, and in their theory. And next is what's the limitation of the phenomenon. Next, the wind speed, the spin will be decreased like the reporter mentioned, but it will be decreased when it's through past the ball. And next, the equation only contains 2 diameters condition. The ball is in 3 diagrams, but they only contain it in 2 diagrams. And the next is they didn't consider the viscosity of the air. And the next is the experiment to label it by the mouth, but it's not stable. And here is the discussion that we can discuss. First, the theory part. we need to discuss about the viscosity of the air. And is it a linear flow or a turbulence? Because it is a turbulence that they didn't have the right direction. And next, that as the reporter mentioned, that it will vibrate. So can they give us a kinetic equation? And next is the experiment part, that they can generate the stable beam by mouse or even hair dry cat. So we need to figure how to fix this problem. And next is the level will rotate and how it affects the phenomenon. And next is how to determine if the ball is picked up, because that they mentioned that it will flow down. And next, the research part, that how airflow will flow through the tunnel, and what is the limitation of the phenomenon. So I want to invite the reporter to give a discussion. So the first is the viscosity of the air. Do you consider it?
No, I didn't, because in this experiment,
Yeah.
the air here is small and just
Maybe the reason why it will rotate is because of the sound.
floating because it rotates.
Yeah.
I don't
Maybe
think
it's not
so.
general.
I think,
Then why the ball will rotate? Can you explain it?
okay, because you blow it with here, and
Yeah.
here will have the air go through it.
Yeah.
Yeah, and the air goes through it. I said it. It will have a Bernoulli's principle here, and that the ball
But why
rotates.
it will rotate in a certain direction? Is it counterclockwise or like, can you predict, if you say, if you have theory to prove it, then can you predict the direction of the rotate?
Okay, and when the air goes through it, it will rotate like this. Okay? In my video.
Yes, in your observation. The video. Go to the video. Okay, so, and the next slide, you said you use Bernoulli's principle to explain this phenomenon.
Yeah.
But Bernoulli's principle is only suitable when it is not a turbulent flow. So you check the Reynolds number. You check the Reynolds number, because Reynolds number is the things that you can predict, that it is the turbulence or a linear flow. So you check the Reynolds number, or maybe we can. So, can you show the velocity of the air? So you didn't check the Reynolds number, so you didn't know if it's a turbulence or a linear flow.
You can
Because
explain
the-
what the number is.
Because if the Reynolds number is the way that you can predict, if the flow will go into a certain direction, or it will occur some turbulence. Yeah, so if the turbulence occurs, then the flow will go like this. It will maybe, because the direction is not in a certain way, it maybe will go like this. And if the Reynolds, so we can check the Reynolds number. So the velocity of the air. And do you have the radius of the ball, of the funnel? Yes. And you can see that in this equation, and you can see that it's actually larger than, and you can see that it's larger than a certain rate. So it is turbulent. So you can say that the turbulent flow is low like this. Okay, so that's fun. And the next part is you mentioned that it will vibrate, but you gave us a stable equation or not maybe a formula. So can you give us a kinetic equation?
What do you want to do?
Like, yeah, a kinetic equation. You only give a stable equation. In your equation, that it will be stable, right here, but in the reality, it will vibrate.
Oh, I say bigger and it will not always be stable. Okay. Because the ball will move like this, and the formula will have, there have some other, because it is smaller, so there will be some other forces here.
But in your equation, that if this part is larger, so the force will make it went up. But you can't explain why the ball will fall down.
Why the ball will fall down? Because I
Or
stopped
vibrate.
blowing it.
Or vibrate.
Vibrate because when we are blowing, in my video, they are steadily, right?
What's that?
Flying steadily.
Yeah.
So, when the wind speed is steadily and the ball here might be more steadily instead of change the.
I mean, if this part is fast, it's larger. All the ball will went up, but it won't fall down. But you say that it will vibrate, and why will it vibrate? Can you explain it? Because it's not a stable equation. It's a kinetic equation. Maybe you should give a kinetic equation. And the expression part that you mentioned that this is the force that will make us also go up. But then you do this, but it's only in Q diameter, but it's a force. You don't want to the circular force is like this, but in your equation, that you can only consider it in a cycle, in a circle. But it is it's in straight diameter, so you should multiply something and make it come into a straight diameter equation.
Did you see my both?
Okay.
Both sides?
Okay. And so the next part is in conduct that the reason why it will rotate is because the pressure of the other air give it the pressure to go inside. Not the ball give the normal force to make it. Not the ball give it the force to make it.
I can explain the contact like this.
If the ball is like this, it will go like through this. That is because the pressure here is larger than the pressure here. So it will give it a circular force to make it smoothly. So the reason why, so the ball didn't mention in this system.
No? I just think that when the contact effect is happen, the air go like this, right? But I just mean that
But why the air will go like this? Can you explain?
because here is the funnel and the air go will touch the funnel because the air just
As
go
you can see, the funnel is like this. Why it didn't go like that, but go like this?
go like this.
Yeah, why it won't go like that? Maybe it will go like that.
Yes.
Yeah, but you said it go like this. Can you explain why? Maybe it will go like this. And also, you only consider, so you say that all the surface force is formed by the ball, but the air has the gravity too.
Yeah, the air have it, but because the area here is small, so the gravity of the air I just neglect it. Okay, because as I calculate.
Okay, so you calculate this will be like this. Okay, but
And can I
can you
explain the
compare?
contact effect?
Can you compare with your theory and your experiment? You do a really great experiment. You train your parameters, but you just put your number back to the theory to prove it's right.
Oh, of course. And you can see this.
Is the limitation of the theory equals to the limitation of the experiment? Is this the same?
What is the
Maybe in your experiment, like if the wind speed is higher, like what's the limitation of the experiment? If the velocity of the air is higher than this number. But is it still a limitation in your theory?
Oh, I didn't measure it because I use a light bulb and I use also.
No, I
that's
mean
not
the
a
limitation of your theory and your experiment are they the same? Do you do it in your theory? What's your limitation?
limitation.
Yeah. Like what kind of parameter? What kind of condition the ball will just pick up?
Just pick up. You think? In my experiment, it did match the theory too.
Then what is the limitation?
Okay. Oh,
Okay, so maybe we can move on. So you didn't consider the impulse to the air is to the ball, right?
because
As we know
Okay, time is up. Opponent, you have 1 minute to summarize the discussion.
First, we discussed about the flow type of air. Is it a linear flow or a turbulence? And next, we talked about the viscosity of the air, and the opponent think that this is the reason why the ball will rotate. And we also discussed about the rotation. And we also discussed that in their formula, they are only considered in the two diagram, but it's actually a dimension. But the ball is in 3 dimensions. They don't consider in 2 dimensions. And also the velocity of the ball, and also the limitation. Is it the limitation in the theory and experiment are they the same? And also we talk about the vibration part. The reporter can explain why it will vibrate. And next, we discussed about the Bruno's and Reynolds number, and also it is suitable in Bruno's equation and conduct effect.
Okay, the reviewer, please take the floor. You have 3 minutes to ask questions.
Okay, I have some questions to ask you both. What is your first reporter? What is your definition of pickup?
definition of pickup,
Yes.
just it can float for over 3 minutes.
3 minutes. And opponent, you think the reporter's definition is right?
No, I think that if the force that the air gives to the if the force that air gives to the force is equals to the weight of the ball, it will be picked up. Or maybe any some impulse of the ball.
So you think
If the force make the ball down equals to the force make the balls up, and this is the definition of pickup.
okay, and reporter, you have said that 3 seconds is your definition of the pickup. And after 3 seconds, will it fall down?
Will it slow down?
After 3 seconds, will the ball fall down in your experiment?
No.
No? Then why your definition is?
Oh, why I use 3 seconds? Because the lighter balls can be blown up longer, but the heaviest ball cannot be picked up that long, just like
Why?
because it's heavier.
But in your equation, if your equation is correct, it means the downward force is bigger than the downward force is smaller than upward force.
Yes?
Just as the opponent said, so the ball can pick up. But you say because the weight, so the ball will fall down.
The ball.
Because you pick up because the upward force bigger than downward force, right?
Oh, you have misunderstood me. That means the ball weight is. I mean that the pressure of the air is, it could not have so much up and down. So when the force made by the pressure and the mass of the ball is when they
Okay, I got your point. Maybe we can discuss later. And what difference between ideal fluid and non-ideal fluid? Because you said the Bernoulli's principle can be used.
Yes.
But Bernoulli principle is based on the ideal fluid. But the real data is not ideal fluid. What do you think about that? Opponent, what do you think about if the fluid is not ideal fluid, will it can be picked up by Bernoulli principle?
We can use Bernoulli principle if it's not suitable because it's in a banana. So,
Okay.
Time's out.
Okay, the reviewer, you have 2 minutes to prepare.
我才20万。哦，对哦，他对他真的不是乱写。还有，去哪个？他的积分是就是错的。
你是拿那个加乘 A 积分吗？我第一次知道这个功能，它其实那什么？这是底细的，底细的，那是底细的，零到开，零到开就是底细的。对。所以他想要什么？
其实你是很少打，
Time's out.
Okay, the reviewer, you have 4 minutes.
Excuse me, the post input, input is wrong.
暂停一下。现在这个是 opponent 的还是？
要切到 review，
对，要切到 review。
可以，这边好。对，这样。对对。
Okay, let's start.
Start.
Okay. Greetings everyone, I'm a reviewer from 我是大帅哥. First one statement, I think the point is pick up the ball and buy the funnel. And overview of the report. In the experiment, he talked about the equipment and parameter is wind and speed and diameter and weight, but in this part he changed 2 parameters at one experiment. She changed the diameter of the ball and the weight of the ball at one time. I think it's not clear, and the phenomenon of the observed. And in observation, she had a phenomenon explains and equipment and video. And I think the phenomenon explained is very clear, but I just have some question about. I just have some confused about this because the reporter didn't give us the definition of pickup. And after I asked her, she said the pickup is more than 3 seconds. It means pickup. But in her experiment, it seems like if the downward force is less than the upward force, then the ball will pick up. But she didn't explain why will the heavy ball fall down after 3 seconds. I think it's some confused about it. And a theory, she thinks the quantum effect is more important than the Bernoulli's principles. And I think it's just like some, maybe it has something to discuss about that. And the result, she said the downward force is bigger than upward force, and it will not be picked up. But the problem is just as I just said, and the conclusion weight of ball, alpha speed and mass is larger, and the velocity will be larger. Next. And for opponent, I think the understanding of the reporter is almost understanding. And the comments for the reporter, I think, is accurate. And the discussion point, I think is relevant, but she just missed some points I think is very important. And the prioritization of the discussed question, I think, is spent well time analyzing the phenomenon. Next. And the discussion with the reporter and the opponent. The reporter says if conduct is bigger than Bernoulli's principle, what will happen? And the reporter says it will be vibrate. But I just think some confused. Because the definition of the opponent of the pickup is equal, is a downward force equal to upward force, then why will it vibrate? I think it's not reasonable. And about the second question is the Reynolds number, and because it will affect the viscosity. I agree with the opponent. And about the viscosity of the air, next, and discussion. I think how would the ball rotate, just as the opponent asks. I think it's very important in this phenomenon because maybe it will, because the reporter do an experiment on the table, just a little distance. Maybe the circular, maybe it's not a circular force, maybe it's a turbulent. Yes.
Time's up.
Okay, thank you.
Okay, and the reporter, you have 2 minutes to make a concluding remark.
Okay, and at first I have to explain that you can see these 2 balls, they are the same way, and they are different sizes, so that is okay to do the experiment. So, and the second, I say that okay, and what will be vibrate? And in the opponent's definition, it says if 2 forces are equal, it will vibrate. But in my formula, I do not write this equal. I just write a bigger or smaller, so it will vibrate. I think it's reasonable. Okay, and the next one. What is the definition of pickup? Also, in the first video, I float it with a ping pong ball and I just take it with a small height, but in the second video, I didn't do it on the table, I just do right here. Okay? And this height is enough, I think. Okay, and the second, you say, as you say that. Oh, okay. And you also say that the speed is not steady in the first video. It will not be steady because it's caused by mouse. Also, okay. And I will show you that video just because that I just want to do it by mouse and just use ping pong ball as the video the TYPT give us. Okay. And the second, we just use the hair dryer to make the steadily because the machine is hard to find. Okay, that's all. Thank you.
Any questions from the jury?
So reporter, how did you measure about wing velocity?
Wing velocity?
Yes. The ball in the funnel on or not?
The ball in the funnel. Oh, of course, yes. I use a machine to measure it. Okay. A machine can measure the velocity. And I also use Arduino to manage the pressure, and use that, and computer will calculate it. Okay.
Okay, please show your page 18. Here you show the pressure up and down. Is this means the pressure PD and PS? This pressure, here you show a pressure down, pressure upward,
Yeah.
right? Is this the definition of your PD and PS, for example, on page 5? Yeah, here also PV.
Yeah, of course.
EU.
It's just the measure rate and the pressure rate and pressure flow. And the pressure flow,
Okay. How you measure PD?
how do I measure it? Oh, okay. I just say that I use Arduino, and I use Arduino.
When you measure PD, is the ball still there?
Yes.
At the same position?
Yes.
And how you probe the PD?
How can I?
How you measure PD? Please.
Make my PD.
How you measure PD?
Major PD. I have to explain it because in my machine, the Arduino is small. It's just like this, and I can put it on a bowl, so just like this one, and the bowl is here, and I just put the Arduino, the machine, on here.
Any wire or something over there?
I put the Arduino here, but I let it on the funnel. Just it will not move with the ball. Okay.
It's wireless. About the sensor.
I use electric dance. Okay. Because I use Arduino, so Arduino will have dance. Yes.
Did you have consider about upward pressure? Maybe have momentum of the flow.
In my experiment, I didn't calculate the.
Just measure.
Yes, I just measure and I use quantum effect to calculate.
Similar problem. Opponent, you mentioned the impulse may be important.
Yeah.
Why?
Because it will give the impulse will give a ball for it to fall. The force is down.
So is this relevant to the vibration of the ball?
Yeah, it may be the fact, but I think the main reason why the vibration is because the velocity will change. If the ball moves more up, the velocity will actually change. So the velocity in the equation will change.
Any further question? Okay, the jury, please prepare the score.你们是用记的还是有拍的？都有，拍的记得要拍的，就三对着镜头就好。 Okay, the score for the reporter, I announced from the fifth jury.
Okay.
5, 8, 4, 5, 6. Okay, for the opponent. 8, 9, 6, 8, 8. For the reviewer. 6, 8, 6, 7, 7. Okay, let's take a 10-minute break.
你觉得被绿化还是蓝化？我觉得所有人都会加10分。
这是我关的。
我的给分标准，给分标准太棒了。
那是我自己。
I have a difficulty on moving out.
If you feel you are prepared, you can start before that. Please start.
I'm the reporter of the problem 17 particle chain reaction. And this is my outline. First, the introduction and then observation, and next is the theory experiment part, and next is my conclusion. And this is the introduction. Wooden particle sticks can be joined together by slightly blending each of them so that they interlock and in a so-called cobra wave chain. When such a chain has one of its ends released, the stick rapidly dislodged and the wave ground travel along the chain. And we need to investigate the phenomenon. And this is my observation. As you can see, when I release the end of the stick, and all the stick will pop out and a cobra wave will be produced. Next is the theory part. First, there are actually two different ways for a particle stick to pop out, and it definitely depends on the way they put together. In situation A, we can see if the red stick is released, all the stick will pop out. But in situation B, if I release the red stick, the chain will pin down first and then pop out. And as we know, we can know that situation B is actually the upside down of the situation A, and all the chain that remained down remained after is situation A, because it's the one that will occur cobra wave. And there, as you can see, that situation A and situation C are actually not the same. And the theory two is that I think Young's model can explain the phenomenon. And this is the formula of the velocity. And while the particle sticks are bending together, the energy will be stored in the bending part. So if I release the ends of the stick, all the force will turn into a kinetic energy. So the stick will pop out. And this is the velocity when the stick straight pop out. And this is the theory. And this is something that I use in the theory. E is the Young's model of the particle stick, and B theta is the function about angle. And yeah, and this is how B theta is, how angle change velocity. And we know that if the potential energy is larger, the velocity will always be faster. And this is the elastic potential energy. We can see that A is the area of the cross section in the applied force. So we can know that if I change the angle, the A will be changed. So the velocity, the elastic potential energy will be larger, and so the velocity will definitely be faster. And this is the theory 3. Explain why a cobra wave will be formed. And you can see that cobra wave will be formed when the stick starts to dislodge. And it happens because it pops out before the chain has dislodged. And you can see this is the picture. You can see when the stick popped out and then it started to dislodge. And that's why the cobra wave is produced. And this is the same way I used to fit the function. And same way I used to fit the function. And m is the amplitude of the wave. If the velocity is lower, the amplitude will be, if the velocity is lower, the higher the chain can get, and the amplitude will be bigger. And this is the wavelength of the cobra wave. If the velocity of the stick is lower, and this part will be bigger. And next is the experiment part. And first, there are two conditions that we need to talk about. First is the B theta. We definitely know that the angle is related to the velocity. So we want to know what actually the relation of theta and the B is. And then the next is the cobra wave. When the stick is dislodged, a wave is produced. So I want to investigate how the sine wave of it. And first, I need to measure the Young's model of the particle sticks. First, I need weight to measure the Young's model of each particle stick. I put the particle stick like a bridge and put the weight in the middle of it. And this is the equation I used to measure. I used to calculate the Young's model. And you can see E is the Young's model, and this will be shown down below. And this is the setup. And as you can see, the particle stick is here, and I connect the middle of it with the string, and the weight is also connected with the string. And this is the experiment. You can see that S is the change of because of bending, and also we can calculate the Young's model by using this setup. There are some measure properties of the particle sticks, and they are all used down below. And finally is the angle part. And first, I use 31 Pascal sticks in the experiment. And in order to make the angle are always the same, I use match in the paragraph, so the angle is always the same. And to put all the sticks together, I use 11 Pascal sticks at first. So this stick won't. So actually I track the velocity of the 12 stick. And here is my setup. And I use camera to track the velocity of the stick when it pops up. And now I need to define the velocity I mentioned down below. First, I will find the minimum position in y-axis, and then I will find the last minimum acceleration before this lower point of the y-axis. And that's the time when I start to track the velocity, because that's the time when the bending energy started to turn into a kinetic energy. And the velocity I mentioned down below will be the 2.5 after the time I start to track it. And the velocity is the average of it. And as you know, when the stick is popped out, the velocity is in x, y, and z axis. So, but I only use one camera to track it. So I turn the stick parallel to the camera. So the velocity is only in y and x axis. And so you can see this is lower point of the y-axis. And so I will find the low minimum acceleration before this point, and then start to track the velocity after this 2.5 seconds and try to measure the average. And the x is the times in second, and the y-axis is the position in y. And here's my result. When the angle is closer to 90 degrees, velocity will be slower. And as you can see that the x-axis is time and the y-axis is the velocity. As you can see, if the angle is closer to 90 degrees, the velocity will be faster. And also I mentioned in my theory part that the A is A is cosecant theta. So so the result fit our theory very well. Oh. And next is the cobra wave. I want to explain that how the velocity change the cobra wave. Yeah. And first is setup. The setup is as same as the last experiment, except for this time I need to track the cobra wave. So this time the chain is parallel to the camera, not the popsicle sticks. And I define the sine wave based on the highest edge of the popsicle stick. And this is the sine wave I use to fit the cobra wave. And the origin is the end of the next stick that will pop out. And the photo I used to fit the cobra wave is actually the one right after the stick is popped out. Yeah. And so this is some example. And you can see that this stick is the next stick that will pop out. So the end of this stick is the origin. And you can see that the red line here is actually cobra wave. I use the cobra wave. And in this example, the sine wave is like this. And the m is 12.5 and the n is 0.1. And so if the velocity is slower, we can know that the wave will be enlarged. So lambda is the wavelength of the cobra wave. And we can see that m is related to the amplitude of the cobra wave. And this is related to the wavelength. And the next part is theta. And you can see that in these two graphs, the x-axis is the velocity of the stick. And the graph right on the right side, the y-axis is the m. And to the left side, the y-axis is the lambda. And the formula of lambda is this. So you can see that it fits my theory very well. Yeah. And next is my conclusion. We found out that the vibrant level, we found out the reason that what kind of parameters will change the velocity, and this is the formula of it. And we also found out how angle changes the velocity, and this is the experiment result. Also the theory result. If the angle is closer to 90 degrees, the velocity will be faster. And next is the cobra wave part. this is the generation of functions. The function of cobra wave is like this. I use this formula to fit the cobra wave. And we can see that if the velocity is faster, the wave will be enlarged. So the n will be bigger, and the n will be, the wave will be large, so n will be bigger, and n will be smaller. Okay, and this is the bending energy that we use to calculate the velocity of the particle state. And you can see that U is the bending energy, and this is the formula. And the kinetic energy of the particle state is like this. And because all the bending energy will turn into a kinetic energy. So you can see that if these two are equal, we can know the velocity is like this is here. Yeah, and thank you.
Okay, the opponent, please ask questions.
Question to page 4.
Don't you think in your experiment the length is too shorter? The length is too short.
Oh, it's just an observation. Like you know that the real length of the chain I used in the experiment is actually 31 of the things.
This century page 6. Oh yes. What variables you control?
And what variables I control? All the variables except for the angle. All the things in the formula is controlled.
The angle is not.
Oh, it's just a theory to explain the two different ways to put the stick together, and the two different ways for them to pop up. It's not my experiment.
Could you see in your
What? Sorry.
Real experiments.
See what?
Real experiment. Yes.
Yeah. I use situation A in every experiment because the situation A is the not this point. Sorry.
Is this into yourself?
Yeah.
Okay.
And it's just
did you control the parallel distance between them?
Yeah, definitely.
Okay. Oh, please turn to page 28.
28. Okay.
What's the M?
M is I used to fit the cobra wave, and you can see that y equal to m sine and n theta minus and in this part n.
Time's up.
Okay, the opponent, you have 3 minutes to prepare.
Time's up.
The opponent take the floor.
Hello everyone, my name is of Staff Cycle Assistant and the opponent of classical chain reaction. The cover statement's main point is to observe the wave front travel along the chain. In the reports, it includes the observation and she has the video and setup, but I confused the setup is some strange, yes, and she didn't definition what is the cobra wave mean. And theory, she used some formula to explain this motion and to measure the Young's modulus. And in this part, I think it is clear. And experiments, the relationship between theta and V. She do many experiments, so this part is abundant and relevant. And in conclusion, she thought angle close to 90 degrees, the V will be better. And the V better, the wave will be enlarged. And she comparison the conclusion to the experiments she told about. And in discussion, I want to ask her, did she exactly check the control variables? Because in his report picture, the parallel distance and the angle is so strange. I think maybe it isn't exactly control it. And I also want to ask she how long did she release the chain after down the chain? Because if she put the chain for many days and make the chain, it will be elastic protect. So I want to ask that. And in his report, she used many formula want to explain, but I'm not clearly understand what the formula work. So I want to explain it. And to Young's modulus, the value I'm not sure it is correct or not. And we can see the wave is the motion is conducting, and another is where the motion it will cause in midway and what force cause the motion. Okay, and in her formula, we can see many theta to V. Maybe it's important to the formula. And some analysis problem I want to ask you. Okay, next discussion. First question, did you experience it's actually check the control level?
Oh, definitely. Yeah, I do experiment by myself, so I definitely check every single point. I don't want the data of my experiment has something wrong.
And since you set up again,
Which setup?
the chain,
The
chess feature.
Third one, I guess.
Okay. Do you think the conductive area will affect the results?
What do you mean? This effect?
Yeah.
Yeah, definitely affect the result because according to Young's models, you can see that. Sorry. You can see that.
Okay. But I want to ask you if you change the theta or the distancing of it, every contact area is different. Do you control it?
Control what? Control which? That part that we
The
discussed.
contacting area.
If the angle is changed, the contact angle is actually changed. They are the same parameter. And the formula is like this: is the area of the contact area is the cosecant theta, and multiplies its square. And you can use calculate it by the.
Will the Pascal become plastic deformation or protect during your experiment?
Sorry, plastic defer.
So the elastic deformation.
Deformation. Will it change?
Yes.
After the state is dislodged, it definitely will change because nothing is the force to make it change, to make it bending.
When the test go by, will it change?
Why would it change? It definitely won't change.
But I think maybe if the test go by, it will. Will.
Excuse me. What do you mean? What do you think will change? You mean the percentage has already dislodged? If the lab bending will change, or the state that haven't dislodged will change? Which state?
Because
you mean this will change or this will change?
No, I mean the deformation.
Deformation.
And it maybe will protect or.
No, the deformation of the state after.
Could you control the release time?
Release time.
Release time after you done your experiments.
I control what?
The release time after you done your chain. After you done the chain.
Yeah.
How
do I measure the release time
of
the stick to pop out?
You down the chain,
yeah.
Maybe put it for 1 day or 2 days and release it.
Then the Young's model of the chain will definitely change. But what will definitely change?
Okay.
Yeah.
And for your formula?
Which formula? Which theory? The velocity one?
Yeah.
Yeah.
And could you explain how this formula works?
What you mean how it works? How it gets or
how it fix me?
Fix me?
Yeah.
The velocity is equal to this. And the fixed
why?
Because the elastic energy will totally turn into kinetic energy in this case. And so you can get some and this is the energy that's stored in the particle state. And this is the
You think the energy only have
the what?
The
energy. Okay.
Yes. Only have kinetic energy
and what? Potential energy.
How about
potential energy is too small because I only track a small time. Like I mean that the velocity here I mentioned is the velocity that is just pop out. It's a very short time, so it doesn't matter that much.
maybe I think the chain will rotate.
No, it will definitely not rotate.
Okay. Then, could you tell me your Young's modulus value?
Value.
Yeah.
Yeah, I put it here. Here, and here's the image.
But
If they need two figures, I can give you a number. I guess. We can calculate it now. Or do you want to calculate it?
do you want to and you release the chain.
Yeah.
Yes. And why the wave it will hold?
Cobra. And if I put the stick together in the situation A, like I mentioned before, the cobra will go before. And why? Because I mentioned it.
Now the third part. Oh, sorry. I also have another question.
Okay.
Did you know the meaning of
The potential energy that's stored in the plastic phase will all turn into a kinetic energy.
I wondering what kind of wave is the
Wave. What actually is?
Traverse or it is
We can only see the wave of the cobra wave. You only see the feature. Oh, I use sine wave to fit it, so you can see the wave pattern in the sine wave I fit.
no. I mean your design.
Oh, I can show you a picture. Like this.
Then why you call this wave is not wave?
It is wavefront, and you can call it wave because the problem statement says
Oh,
that
wavefront.
is a wave. Yeah.
This what? This meaning?
It's just an equation, and we simplify the equation, so we
But
get
it's
it. But
a-
actually, I can put the math out, and you can like make it more harder, I guess. And the rho equals to the mass.
I mean, this equation it is we use to the study
Sorry, to actually.
the study longitudinal. Yes.
Sorry, what is that?
Okay.
Actually, okay.
And you put the chain on the table, right?
Yeah.
And do you think the table material will affect the result?
No, I think the material of the plastics will affect the result more and a lot more. Just the Young's model will change a lot.
The wave it is only will go up, not go down.
The way, oh, it will actually go down, but it is in
But
situation B.
But you said the table's material.
It's only in situation B that you can see. You can see that this is situation A and this is the situation B. Sorry for this. And you can see that the chain will, the cobra will only go up, and the chain will dislodge here, and all the things will
I
come
think
down.
this part is connected to the table, so
But
for the table, if you are lost or
but like you can see now, my hand is connected to another hand, but it definitely
oh,
goes
so
back.
could you
Two
draw the
things
free
back.
body diagram for me? Free body diagram.
Free body that.
Free body diagram. The force to the motion or one.
Sorry, can you explain that? I really don't know.
The force to the chain.
The force to the chain.
Whole force. Free body diagram.
Hands up.
Okay. Okay, the opponent, please summarize the discussion.
As we discussed between the two reports, we discussed about harmful. Is she really control the variables? Then, but I think according to his picture, it can prove it very well. And the contact area, I think the contact area is related to on the different angle it will cause the contacted area different. And the air after the sticks, I don't know how she's think about it. And the theory, I think.
Okay, time for the reviewer to ask questions.
First, I have a question to ask the reporter. So, the total stick you use is one type?
Or what do you mean
One type of teeth.
Oh yeah, definitely.
So, how many times you do your experiment?
Several times.
Several.
Really too many times. Too much that I can't want to see about the state again.
Okay. I understand. So, since your main point of this phenomenon is the Young's modulus?
What do you mean the main point? I use Young's modulus to explain a lot of things, but I think the main point is the cobra weight and also the regular dislodge, and in other words, is the velocity.
So, since I think this theory, there is a Young's modulus, right?
Oh, definitely. The E is the Young's modulus of the particle field.
So you think that you need more sticks to get more Young's modulus?
Oh, I use like 40 sticks to calculate the Young's modulus. I really did a lot of experiments.
I mean is that the different type of sticks and you have different Young's modulus.
Yes.
So you only use one sticks to explain the Young's modulus?
But I think the main focus of this problem is the velocity, also the cobra weight.
Okay, so you don't have the parameters, only the angle, right?
Parameters and the velocity, if you talk about the cobra weight.
I mean, what's your parameter? It's only the angle, right?
Only the ankle, but as you can see in the problem statement, we only need to investigate the angle.
Okay, and as you asked that, do you think the material of the table will influence the velocity?
Oh, because I think the web it will go up and go down, so the velocity it will.
So you mean the wave, the curve we make will be go up and down? What's your meaning?
Oh, as you can see, it goes down, but I think if it is brought in the air, it will go down. And as we
So the wavefront is going up and down. If
I think it's yes.
so, the wavefront of the cobra wave you think is going up and down, not just going front, right?
Yeah.
Okay. And do you agree with the opponent?
Not actually, because in situation A, I only do the situation fit the phenomenon. So in situation A, the stick will occur a cobra wave, and then the stick definitely will fall down. But it's not the point that we are focused about, as you can see in the picture.
Okay, and this is all of my questions. Thank you.
Okay, time for the reviewer to prepare. see.
Time's up.
Okay, the review, please start.
Hello everyone, I am Yuti Zhang from Team Anonymous, and today what I'm going to talk about is particle chain reaction. And what we need to investigate is when we join the sticks together and release the end, and there will be a wavefront traveling along the chain. And this is the outline of the reporter. They talk about the Young's modulus and the relation between the theta and the velocity. And their observation and the conclusion is when the angle is close to 90 degrees, the velocity will be bigger. Okay, next one. And I think there's some pros and cons for the reporter. First, I think they have complete experiment and they express clearly and great. And I think they complete the theory formula. But I think there are a little bit lack of video since they just demonstrate a short one, so I need a longer one. And I think the video is not clear enough since I said in the first point. And the popsicle is not set in the same in the picture. And I think they should explain the angle. In the theory, they just draw a line like this, and I need more explain. And they didn't mention the energy of the height. And next one. And I think the pros and cons for the opponent is they have enough question, but they don't talk about the theory and the phenomenon because they talk too much in the experiment. And since they ask questions and they don't ask a further question, and I think it's a little bit pity. So what I want to hear is more phenomenon and theory. I think it's a little bit. And the next point. The question is the length of this chain is set too short, and they say it's just an illustration since they use 31, and I think they can change the amount to find if there is any influence between the amount and the velocity. And the next, they exactly control the variables, and I think this is very good. And next one, contact area effect. If the angles change, and they said definitely. So, but they say, since they say it's the same variable, so I think it's okay. Next one. Explain the equation, and they say by energy conversion, but I think the equation of the use is just not, they can just not just only explain by energy conversion. I want to hear more about it. And next one. Free body diagram. Okay, I think this a little bit nonsense. And since they just use, they have only one parameter that is the angle of the chain they arrange. So I think the reporter can use more parameters to make the experiment more clear, and we can know more about the experiment. And the opponent, what I say is you can talk more about the theory and the phenomenon. I think you ask too much question about the setup. And this is all what I want to say. Thank you.
Okay, concluding remark of the reporter.
First, the different material can be proved in the theory because it changed the Young's model. But the puzzle sticks isn't a problem that the problem statement. The popsicle is not the because it is not the problem statement asked for, so I didn't do the experiment. And the exam pattern, the error will be same. And next, if the intentional deformation are the same, the deformation can store in energy. And next, as for rotation, there's no rotation in a small time. In a small time, it will change, and the cobra wave can be determined as in the wavefront. And next, the wave direction is related to the two situations. Yeah, and that's it.
Okay, questions from the jury.
About the velocity.
Oh, the velocity part.
Yes. Yeah, this one.
Yeah.
Follow 3. About this velocity is the speed or the wave.
Oh, the speed. I did define my velocity here in the experiment part. Sorry. Here. And the velocity is the average of these 2.5 seconds.
The speed.
I think it is not the only stick is the whole chain's velocity.
I agree with the opponent. I think it's the waveform's velocity.
Okay, I have one another question. Did you have tried to release the chain from different edge?
What do you mean different age? Because the two parts are the same. They are.
From this one release or from this one release?
Oh, they are the same.
The same?
Oh, what do you mean? In situation B and situation A and situation B, the pattern is like I put them together like this, and situation B is the upside down this.
Another one? Another one is different or the same?
Oh, they are different.
The situation to the two add to release it is not. I think it is not. It's not the same because the force to part Y is not same. Yes, the force.
Situation A means this and situation B means this, or the release point is different.
Or if you when you cross the same or another the same?
Yes.
This kind or this kind?
I think it's different. My point is saying sorry.
If I release one end, then it may be situation A or situation B, and the other will be another situation.
How different?
First, the force will make it ping. Well, in situation A, it will pop out, but in situation B, it will ping down and then pop out. Pop up.
Did you have see next wave?
The wave will only be occur in situation A. Like you can see that this is a cobra wave and this is not.
Any other?
For report. So you use several formulas in your slide. My question is, how did you get the formula? It should be start from the initial model or some model at the beginning. For example, spring model or something. And that formula could be a solution of the partial equation. So could you differential equation? So, okay, my simple question is, how did you get the formula?
We calculate this. We first know the potential energy that's stored in the partial disk, and then we think that it will equal to the kinetic energy, and they are the same because all the energy will be turned into the kinetic energy in a small time.
So, didn't you have any reference book or some reference model to get the formula?
We both calculated, and we also see some reference.
See some reference?
Which reference?
Which reference? I actually Wikipedia. I see from Wikipedia and some. I actually don't remember. But I searched for it. I had a.
That's okay. So you say from Wikipedia?
Yeah, we both Wikipedia and some.
Did you have compare the theory model and
Yeah.
one formula and your experiment?
There are different there are different restaurants in the on the website. And yeah, I definitely. Oh yeah, yeah.
Okay, any further question?
I have a short question. You have a equation y equal to m sin theta, blah blah blah. You sure? Yeah. What's the meaning of n theta?
The n theta.
Yeah.
N theta is the wavelength. This is the wavelength.
Why the wavelength related to theta? N is the it means how many wavelengths?
It's the wave number.
N is wavelength. Okay, and what's theta?
What theta is the wave number.
Theta is the same as your definition previously?
Oh no,
The
they're
angle
not the
between-
same. Sorry, they're not the same. We didn't mention.
It's not theta.
No, no, they are not the same theta.
Okay.
Okay, time for the jury to prepare the scores. Okay. Are you prepared? Okay. I will announce the score from the front to the end.
Okay.
For the reporter, 8, 6, 6, 9, 5. For the opponent, 6, 5, 4, 7, 5. For the reviewer, 9, 7, 5, 8, 6. Okay, let's take a 10-minute break. Please put the name of the representative of each team.
他是不是一场上台才出来？不行，根据规则不能上台。有，我有办。我记得他第一台有，这一台也有。是这样。 慢慢。如果出现 off， 然后 outline 是说内容，就刚才说的自然。
那个换
低等卡。
等一下是先他们啊 ，reviewer 应该是比较后面。我是说等一下是先他们，然后后来才是 reviewer。Okay, the reporter takes the floor.
Greeting everyone, I'm the reporter from from National Zhanghua Girls Senior High School. Today I'm going to report to you the problem number 16, thinking bubbles. The problem statement is observe a bubble in liquid in oscillating container, and the bubble will move downward instead of upward. And this is the outline in my presentation. I will show you the setup, the observation video, the data analysis with a model we built, and the conclusion. This is our experimental setup. We use a power device, to produce the stable wave and use vibration exciter and stick the container on the vibration exciter so we can observe this phenomenon. And we have built artificial bubbles with the thin shell of 0.5 mm. And the bubble is compressible. And this is our observation video. You can see with the container oscillate, the bubble will fall down. And the frequency is 18 Hz, and its acceleration is 26.08, and it's a slow, and this is a slow video. And as we can see, after the bubble moves down, and we start to vibrate. If we start to vibrate, the bubble will flow up. So it's proof the bubble sink not for its gravity. The bubble sink not for its mass. It's just for the vibrate. The point is vibrate. Yes. And this is the observation trajectory. The frequency is 60 Hz, and the maximum acceleration is 33.32. And we can see the bubble sinks step and step. It will go upward and downward and upward and downward and finally sink. Analysis of the phenomenon, we can see a slow video. In this slow video, we can see the bubble with the container shake. The bubble will deformation. You can see this part of the artificial bubble is pressed and stretched. So we can know the bubble is deformation in the container when the container vibrating. And why the bubble will deformation? It's because if the container acceleration is upward, like this, and the water, because the inertia, so the water will press the bubble to smooth, to flatter, and the cross section of the bubble will bigger. But in this part, the bubble is because the effective gravity is downward, so the buoyancy is upward, and the bubble is trying to move upward. But because the cross section of the bubbles is bigger, so the bubble will move upward maybe like 5 cm. And when the acceleration is downward, because the inertia, so the water will press the bubble, so from the horizontally, so the bubble will stretch out. And because in this part, the bubble is trying to move downward because the effective gravity is upward. So the bubble will move downward, but because the cross section of the bubble is smaller, so it will move, the distance it moves will bigger than this one. So maybe 7 cm. So we can see just like this structure. Yes, it's why I think the bubble will sink. And this theory is based on the based on the acceleration of the container is bigger than the gravity. And this is my experiment variable. I change the frequency and change the maximum acceleration, and I keep the vibrator without the standing wave. So the standing wave won't affect this phenomenon, and the vibrate is symmetrical, so it won't affect too. And about this, the first variable effect of the frequency, we can see this is the maximum acceleration is 15.94, and I change 4 frequency. All of this frequency won't be synced. And also we can have a small result is maybe in the same frequency, maybe we change the frequency won't affect the sinking bubbles. Yes. And this is the effect of maximum acceleration. We can see I control the frequency and change the maximum acceleration, and we can see if this is the biggest acceleration, and it's the maximum acceleration bigger, the bubble will more easily to sink. And we can see if the maximum acceleration is bigger, the bubbles will sink to the bottom of the container more easily and in short time. Just like this channel. All of it is matched with this theory. Yes. And this I have built a model to imitate this phenomenon. And this is a simple model about the phenomenon that this is low V, MA. Low V is M, and this is A. MA equal the buoyancy plus the drag force. And in this equation, I calculate the drag force, and the drag force has some relationship with the cross-section area, and the cross-section area is related with the container vibrate. Yes, and this is the compression acceleration. And we can see this is the model's data, and this is the maximum acceleration is 11.59, and this is the 15.94. We can see at this maximum acceleration, the bubble will float, and in this, the bubble won't move, just vibrate at the ground, just vibrate at the place. And next, in this part, we can see if as the maximum acceleration bigger, the bubble more easily to sink, then the angle will be bigger. Yes, like this. This is the biggest acceleration, and the bubble will sink too. As I need to explain about this line. This line is not trend line or something. It's just let me to easier to show you about this phenomenon because the angle is very small. So I put all of the lines, the angle in same diagram, and we can calculate. We can get it the diagram. Okay. We can get this diagram, and it shows us the smaller maximum acceleration is, the more harder the bubble sink. And this is the comparison with the real data and the models. The real data is more easier to sink than the model. I think that's because some complex variable, but the simplest one I can calculate, and the important one I think is add mass, because the add mass is relative with the velocity of something in fluid, and this is the add mass equation. Yes, and because the add mass, if the bubble moves downward, because in our presentation in my presentation before, I had said that the bubble is seen more, the bubble moves downward more easily than move upward. So the velocity downward is bigger than the velocity upward. Yes, and the add mass will affect less too, because the velocity downward is big, so the add mass downward is big too, and the add mass upward is smaller, so it will more easily to sink. And this is my conclusion. Because the deformation of the bubble will affect the resistance, so the bubble will tend to sink. And the point of sinking bubble is deformation of the bubble. Just as I said, because the container vibrates, so the bubble will deformation and the cross-section will affect this phenomenon. So the bubble will tend to sink, but the sink not just a sink. It's just like floats downward because it's effective gravity change. It's not because of the mass. Yes, and so this is my presentation. Thank you for your listening.
Time for the opponent to ask questions.
So I have some questions to ask you.
Yes.
So you fixed your radius of the bubble by using that green thing?
Yes.
So did you use a real bubble?
Yes. But if I use real bubble, every time I do an experiment, I can control the value of the bubbles. Yes, and I said I just try to imitate the real bubble as please turn to device. Yes, set up. Yes, the shell is very thick and it can compressible. And in the video, we can see the bubble can deformation.
Okay, so you use the line to contact on the bubble?
Yes, and the line is very thick too and very soft.
So you think this line won't influence any factor?
Yes, it will affect, but because I keep the line is very small, So I think it won't affect a lot.
So, do you think the depth you put the bubble will impact the sinking bubble?
The depth?
Just where you put your bubble is here, and do you think if you put the bubble there, it can be deeper or less deeper, and the phenomenon won't happen, or it will still happen?
I think if I put because I use the tip to prevent the surface wave. So I think the depth of the bubble won't affect.
So you say even you put the bubble on the top?
Sorry, I'm exactly less. If the maximum, because the depth is
Okay, time for the opponent to prepare.
Time's up.
Opponent has the floor.
Hello, I am the opponent, Ting Zhang, and I'm from the team Anonymous. And today, what I'm going to talk about is the sinking bubble. And what we need to investigate is when the liquid, a container of liquid oscillates vertically, and the bubble will move downwards instead of rising. And I think there are some pros and cons for the reporter. First, they have a good experiment set up, and I think they have a good volume and good model of the experiment. I think they should speak more smoothly, and I think the video is clear, not clear, since I think they must put a real bubble, not just I don't know what is that material. And next, and I have some question to ask the reporter, so how do you measure the data, but by what, or, and when the frequency is smaller or bigger, and what will in fact affect the results? And in page 7, you tie the thread on the ball, and what is that, and would the thread change the phenomenon? And you say no, but I want to know more. And next page, and I think I want you to explain your principle more clearly. And according to your principle, is the pressure going right? And I need you to explain the formula more clearly too. Next. And how do you measure the data in page 16? And why do your data differ from the module? Since you say there is complex factor, but I don't know what complex factor. This can't convince me. And next. No, this is all I want to ask. And you will skip this.
Okay.
First, I want to ask, how do you measure your data?
How do I measure my data? You mean exactly my data? Exact my data?
Yes.
I do the experiment for 2 times and try to take the average. And the 2 times is very small difference. Yes, the difference is very small.
So you don't think if you do more times there will be more different? You just think that 2 times is enough?
No, I think because the experiment won't be enough anymore. But I don't have much time, so I just do two times. But I think that won't affect a lot.
Okay, next question. When the big frequency is bigger and smaller, and as your attention to the frequency,
Reducing there.
so this is, you think when the frequency is bigger, and what does it influence the result?
Oh, it's a detailed problem. Can I use the background?
Yes.
Oh, sorry. Because the frequency, because the acceleration is equal to the frequency. Like this.
Yes.
Yes. So the frequency will, if I control the acceleration,
Yes.
I change the frequency,
Yes.
and I will affect the amplitude. Oh, sorry, amplitude. I will affect the amplitude.
Yes.
Yes. So if I change the frequency and I control the acceleration, the amplitude will be bigger. Just as the figure shows us, the amplitude will be bigger.
And the frequency, what did the frequency influence the depth? I mean, when you do your experiment, you just connect a line like this.
Yes.
And how long is this line? Did you?
Oh, yes.
And
10 cm.
And did you change it?
No.
So you think in any depth the bubble will sink, right?
Actually, I think because my container is at most is 25 centimeter.
Yes.
And I think 25 centimeter won't affect a lot. But if it's maybe 25 millimeter or 25 kilometer, it will affect.
I mean, if you put the bubble here, it sinks.
Because the surface wave will affect, but because I use the top to prevent, this is of the bubble, yes, to prevent the surface wave.
Yes.
So I don't think this will affect.
So you think, no matter where you put the bubble, and the bubble will sink.
No, I need to exactly expand again because I need to expand again because I said it's the extreme will affect. But in 25 centimeter, I don't think
you think in 25 centimeter it moves in fact a lot?
Yes.
And then we'll skip to the next question. That I will ask the same question again, that do you think the thread will influence the bubble? Since if the nature bubble and it have only the resistance in the imaginary power force and the bias force, right? And when you connect the bubble on the thread and there will be a tension on it, so you don't think there will be influence?
Yes, it will affect actually a lot because we can see in this diagram, maybe these bubbles will float, but why it didn't float is because the tension of the rope.
Yes.
Yes,
So
but because if I change if I didn't fix it on the button, maybe it will affect by the by the vibrate, and I need the bubble to keep in the water.
So maybe what you've done is not thinking bubble, but just
yes,
effect
it's
of the
thinking
tension.
bubble. Actually, I do the natural bubble and the artificial bubbles.
Yes.
Yes, but I didn't put my PPT. Sorry.
Okay. That's. And can you explain your principle more clearly to me?
Principle means.
Or your theory.
Okay, it affects this one, right?
Yes.
I say this is the container.
Yes.
And if the container's acceleration is upward,
Yes.
the effective gravity is based on the acceleration of the container is bigger than gravity.
Yes.
Yes. And if the acceleration of the container is upward, the effective gravity will downward.
So you think what influences the power is not the imaginary force?
Yes, it's imaginary force. And I said the effective gravity is computed in imaginary force. Yes.
Okay, so in your theory you didn't mention the tension and you didn't calculate your tension, right?
Yes.
So, okay. Then according to your principle, do you think everything's right? I mean the pressure or something?
My principle means this one.
Yes.
Oh, actually I didn't focus on the pressure because I just focused on the deformation. Maybe the pressure will affect, but I think it won't matter a lot.
And next question, that what material you use is that green thing?
Oh, the green, actually the bubble is transfer, but because it's hard to everyone to see, so I use marker to mark it. So to green, it's hot melt glue.
Oh.
Yes, because the hot melt can compress. So, and I use a.
Okay, and do you think the material difference and maybe the bubble, when the bubble, nature bubble, have the force like 5 Newton and it will goes like this, and your bubble, because it's maybe harder or softer than a bubble, then it will change its.
Yes, you got the point. In my model. All this. In my model, there is a coefficient of this one is the coefficient of the compression force. Yes. Should I show you the formula of this? Okay. Okay. The formula is the N is cross section of area. Next. Like this.
Yes.
And I use tracker to check these two coefficients.
So how do you get the average?
Average? No, maximum. Maximum average.
Yes. So how do you make sure your maximum is the short maximum?
Actually, because the definition of this equation
Yes.
is in the water isolate. In the water it isolates, and the maximum of the cross-section, the maximum of the cross-section of the bubble.
And I want to ask, you said your data and that the comparison page.
Okay.
No, not this one.
Oh, it's not.
No.
This one.
This one. And can you tell your opinion to me?
My opinion.
So why do you think that your data is different from the model?
Oh, I have said the important things about these two different is add mass, but because it's a fluid and it's not ideal fluid. Yeah, so it's very complex. Maybe there is some very small turbulence or something will affect that.
Okay, so how many times do you do this data?
This data?
You did just
Because the blue one is model,
yes.
and I take all of my data to talk 2 times.
So this is the position the bubble thinks, right?
Yes.
And I can see some dots are not.
Because it's just some track dot. Yes.
Also, you just use the tracker to track this.
Yes.
And you said you did the experiment several times and is
2 times, not several.
2 times, and is the position of the bubble same each time?
Position of the bubble.
Just this chart.
Yes.
You check both of them.
Yes.
And they look the same.
They look the same. The step is step, but not. It won't be everything.
I know. So I mean the
This is
tendency that your data is lower than the module, right?
yes.
Then the first time and the second time.
Both of them is lower.
So did you get the average or you just use one time?
I got the average.
So this is the average.
Yes.
So in my opinion,
Oh, you suggest me to do 2 times.
yes, and if there is the average, I think that maybe you can put the error bar in it.
Okay.
Okay, and this is all of my discussion. Thank you.
Okay, the opponent, please make a summary.
Okay, for first of it, the reporter said that the depth won't influence the thinking bubble, but I think if the bubble doesn't sink deep enough, then there won't be a sinking bubble phenomenon. And I think what the sinking bubble phenomenon, the position of the bubble will look like this. So I think if it's not deep enough, that the bubble will just go down and rise up. So since the reporter said the deep don't influence the result, I think this is wrong, and
Time's up.
okay.
Okay, reviewer to ask questions.
Okay. Question for the reporter. Do you use your shell in your experiment? Do you think that the elastic force or the shell mass will affect the experiment?
Yes, it will affect. Actually, the bubble's density is 0.001 and mine is 0.0444. Yes.
Okay, then so and you use this is the fluid effect. So do you consider the viscosity in it?
Viscosity? No, I didn't consider it, but I just used one bubble, so I try to do my best to prove.
Okay, so you mentioned the deformation. Why there is a vertical deformation?
A vertical deformation?
Yes. make it longer?
Because the
Why will the deformation be longer? And
longer, because the fluid will, the inertia of the water will try to stay at place.
okay. So what do you think about this?
This means the theory,
The vertical deformation.
the vertical deformation.
Okay, let's move
I
to.
can show you some diagram.
And here's the next question. You use your shell in the theory and in your experiments, and the volume will not change, is it right? The volume will not change.
Yes.
But in the reality, the real bubble will change it. The volume in a different depth, deep in the water.
The volume, actually, is the density won't change.
But the volume will change. And
Yes,
so,
and the volume will change too, because the compressible.
So,
This bubble
okay,
is
so,
compressible.
so you didn't consider the buoyancy in this theory.
Yes, I have.
But
If there is no buoyancy, it will
But
sink. It will
you
sink.
use your same volume as the shell has, and the buoyancy will not change.
Actually, the shell is compressible. So
Okay.
the pressure will make the deformation and the volume will change.
Okay, so what do you think for this point?
I think that the material, the reporter changes will influence the result. This is because the bubbles, the main point that to make the sinking bubble is that the volume changes, right? And since the volume of her ideal bubble or what doesn't change like a bubble, that I think the sinking bubble.
Okay, thank you. So, and you use for the report, you use the field jack force, and do you consider the jack coefficient?
Drag coefficient, yes, I have
But you said that is a deformation, but you didn't calculate in a different situation at
Yes.
the different times.
this one.
But there's only the crossing area, not
Yes.
the jack coefficient.
No, there is a drag.
So,
But then you didn't say that you will change.
Time for the reviewer to
and the
prepare.
Okay, thank you.
荧幕去给他们。 Okay, the reviewer, please take the floor.
Hello, dear jurors and the professor. I'm teaching now from Team Today I'm going to review the column 16 sinking bubbles. And here's the common statement. And I think that the main focus is why the bubble will move downwards. And here's the reporter's online. And she gives the observation that you use a fixed frequency of 88 Hertz to do the observation, but they didn't mention what is the bubble observed, and if they use the shell to the shell that will not be the reality bubbles, and they give the theory that the gravity and the deformation may be the reason that can drag the bubble to move downwards, and they didn't say the result of the equation, and they didn't consider the viscosity of the fluid, and they give the setup using a vibration and an amplifier. And in their experiment, they do the experiment about the frequency, the max acceleration, and the effect of the bubble mass, but they didn't consider the mass of the whole system, and they didn't tell us how they measure the acceleration with the container on the vibration. And here's their conclusion is that the deformation will affect the resistance to make the bubble thing to sink, but they didn't feed their result to their theory. And here's the opponent's outline. They say that they have a good model and experiment, but the principle and the theory is not clearly explained, and they do the experiment not enough time. And here's the discussion. First, they talk about the data of the experiment, and I think that is the experiment's lack of data, and the frequency effect. And the opponent think that the frequency will affect the bubbles, and the report said that it can be explained by the amplitude and the frequency. And I think that's the result from the theory and what's in the reality situation. And here's the discussion about the string connection. And the opponent think that the tension of the string could affect the result, but the report said that it will affect, but it can prevent the ball from flowing up. But I think the tension it will not be the most important part, but it will change the flow direction or the flow type in the container. And here's the pressure and pressure tolerance. And the opponent think that pressure isn't calculated in its theory. And I agree with the opponent that the volume will change in different and here's the point is that the viscosity of the fluid is not mentioned that would drag the bubble, and the pressure of the water is ignored. That will force the buoyancy will force the bubble to flow up, and the volume of the bubble will change in the reality, but the elastic force of the shell will affect to the result, and they didn't match the result to the equation, and they didn't talk about the acceleration measurement because the container will change the acceleration, and they say that the shell is compressible, but they cannot see in the video.
Concluding remarks of the reporter.
Okay, thanks for the opponent and review, but I think there are some misunderstanding. First reviewer, he said my equation, I show my equation of, I show my equation of the theory, but I didn't put it on my data. Actually, there is, and I have discussed with the opponent. I think I say because as the equation, so the amplitude will be bigger, and we can see in this graph. Yes, and about the artificial bubbles, it's compressible, so the value will change actually. Yes, and in my model is consider the stress too, the pressure too, and because the pressure, so the bubble will deformation, and the depth of the bubble is very important, but in 25 centimeter, actually in 15 centimeter, it won't affect a lot. Yes, but maybe in 15 meter it will affect a lot, but it won't in 25 centimeter. And about I make a factor, and this I think myself because the opponent say if the pressure is good not enough, the bubble will think like that. Actually, it has something wrong. If the depth is not enough, it will affect like this, step to step. But the y-axis actually maybe 25 meters. Yes, so the depth will affect just in very extreme diameter. Yes. Thank you for your listening.
Okay.
Okay, questions from the jury.
Just as the initial condition. So for your experiment, so the bubble is at the maximum depth, then you start to oscillate.
Oscillate working. Yes, yes.
So first, wait the bubble to the maximum depth, then oscillate. Is that right?
Yes.
Okay. Then the initial condition will be different. So you can imagine that if the bubble is at the maximum, then there will be force to keep it at the position instead of even throwing up. So this is the question for all three. So compare with three initial conditions and this initial condition, how would that affect the phenomenon?
Yes, I think the tension of the bubble, because it will vibrate in my experiment, maybe it will give the bubble an inertia to move downward. Yes, but the inertia is very small because it's a fluid and the Reynolds number is very the drag force is very big. Yes, maybe it will affect, but actually in my experiment, the density of the line is very similar to the water. So the line is always like this. Oh, sorry, it's not stretched at all. Yes.
How about you?
So I think that in the bubble in the different will have a different volume. Then the buoyancy will lift up and blow up the bubble. So in some initial condition, the bubble will not be sink.
And when I think maybe she said that she said that 25 centimeter is not deep enough to make the bubble rise up. But I think maybe because she connects the bubble with the line, so when the bubble wants to rise up, but because the tension, the thread gives the bubble, then it can't rise up. So I think there must be some error in her experiment.
I have a question for the reporter. Please show me your data, for example, page 9 or page 16. Okay, we see the position of bubble oscillate, right? So if the frequency of your system is, for example, 60 Hertz, the bubble will oscillate 60 times every second, right?
Yes.
Okay, so maybe page 16 or page 9, any data. Okay, so for example here, we see for example
Sorry,
for 1 second.
the axis is wrong.
So what?
The axis is wrong axis. I didn't mention.
So what's the actual frequency or actual time? What's
The actual frequency is 60, but the axis is wrong.
okay?
I have some problems about
So the axis may be okay. I see. So other data also has similar problem. For example, page 16. Or the time also not correct.
No, yes, that is correct.
Really?
This is.
So for example here 0.1 second it's oscillate for 1 to about 3 times, but your frequency is 60 Hertz. So I estimate the frequency is only 13 or 14. But so are you sure the axis of time is right?
Maybe have some wrong, sorry.
Okay, and about your simulation, okay, any simulation result, please show me. Okay, so here also have some question about the frequency. All of your simulation data, please show me another page. Okay, for example, here you have different acceleration, but these data have the same frequency.
No, not 60. This one is maybe 20 or something. 20.
So you mean these two
Yes,
you
but
have different frequency?
Yes,
They have different frequency.
these,
Yes.
the models, no, same frequency.
Same frequency.
Yes.
So how you control your maximum acceleration?
Maximum acceleration. I use tracker to track the amplitude
No,
and use that.
I mean in your simulation.
In,
How you calculate your maximum acceleration? This is the simulation result, right?
Yes.
So you have the same frequency of these two videos,
Yes.
right? And so how you decide the acceleration from this video?
Because I have calculated the acceleration by I just write on a blackboard equation. So if I change because I fix the frequency, so I change the maximum acceleration and amplitude will change too. So
Amplitude?
yes, amplitude. So you can see.
Really?
Yes.
I see they have the same amplitude.
No. This amplitude is to 0.1 and this is 52.
Oh, okay.
Yes.
So bigger. Okay.
Any other question?
Yes.
Okay. No question?
I have next question for all of you. In your case, you say some deformation happened, although you do not have some explanation about why the deformation. Maybe you have a review, but I ask another question is, do you think if you have larger acceleration, that means you have a larger effective gravity, will this effective gravity influence the size of your bubble?
The size? Yes, it will affect.
So if your effective gravity larger, the size will change?
The size is the value.
Area or value?
Yes, it will change because of pressure.
Okay, so how about?
Yes, and but the equation will change at the same time because the size is the value for the shape will affect the result, like the coefficient of the jack or the points.
So why the effective gravity changes the size?
I think this is, you mean the gravity will change the size?
Effective gravity.
I think this is because when the amplitude is bigger and then maybe the amplitude is smaller, then this will pull the bubble like this. But when the amplitude is bigger, it will pull the bubble like this one. So I think this will influence the final results.
So yeah.
Amplitude.
You mean amplitude changes the shape?
Yes.
Not the size, not the volume.
The shape and the volume will be changed.
I'm sorry. I want to prove that the compressible and the deformation is the main point about the thinking platform. This is a BB ball, and this is a BB ball, and this acceleration, actually my compressible ball will sink, but the BB ball won't sink. They have same depth and same volume. Yes. So this ball won't sink because the BB ball is incompressible. So I can prove it. Yes, thanks.
Okay. Time for the jury to prepare the score. Okay, I will announce from the front. For the reporter, 6, 7, 6, 8, 5. For the opponent, 7, 7, 6, 7, 7. For the reviewer, 7, 7, 8, 7, 7. Okay, and let's continue this tournament.
他最高加速度大于这个多米加速度的话，他不会飞行。
应该是他会把那个桌子都撤起来，还把一个东西就把它头上震起来。
但是这样少对加速度就有因为它下面也在震。
结束。
依据他的理论。
我的错。
对。